We are venturing into chapter 19. The title of chapter 19 is enolate. Enolate. Chapter 19. Let's put that here. Chapter 19. And let's explain where that comes from. We got pKa up here of, what you got? 20. That's an alpha H. So I've got hydroxide in this question. In an equilibrium that looks like it's unfavorable. What's that mean? Unfavorable. Why is this called an unfavorable equilibrium? If this is my desired molecule on the right. That's right, I'm going from 20 to 16. HOH 16. That is not good news. But I'm going to posit to you that this is excellent news. What? Wow. Well, pKeq, this stuff never goes away, does it? You think I'm going to stop asking about pKeq? Never. 20 minus 16 equals 4. What's KEQ? 10 to the negative 4. And this guy actually has a more stable, now that's not equilibrium there, is it? What kind of arrow is that black one over on the right? Resonance. There's a more stable resonance form. Yep. And it sounds like test 1 again, doesn't it? Oh, you want even a more stable resonance form? I'd say the geometry is a little more favorable there. There you go. That's called an enolate. That's where it gets its name. I mean, the whole deal is called an enolate. After which of these two resonance forms? This form. It's got an ene and an O minus that resonates. Oh, we did it again. What does ATE mean on the end of an ion's name? It's a resonating oxygen. 8, resonate. It does that. It's got an ene in it too. Yeah. Okay, so there you go. Unfavorable equilibrium. There's a ratio of KEQ equals enolate over aldehyde, right? Equals 1 over 1, 2, 3, 4. That's not 10 to the 4th, is it? 1, 2, 3, 4. It is 10 to the 4th, isn't it? Right there. So what is the enolate surrounded by? 10,000 aldehydes for one enolate. What? So what's the enolate going to react with? You already said it. Aldehyde. What part of the aldehyde is most interesting to the enolate? The carbonyl, because the carbon is quite positive. This is the exciting part right now. There are 10,000 of these for one of these. That's what we just figured out. It attacks the positive carbon, and it makes an exciting new carbon-carbon bond. We have a name for that. When you make a carbon-carbon bond. What's the name of that process? Synthesis. Where the money is. Okay. Why are you red? I want it to be black. Yeah. And then I just need to get a proton on there. Where are we going to get this proton from? I gave a clue with its color. Where's that proton come from? H2O. Oh, I used hydroxide at the beginning of the mechanism, and I'm making hydroxide right now. What role did hydroxide play? Catalyst. Can I write a meow for old time's sake? There you go. We had approval in the front row. So that there is called Aldol reaction product. Aldol reaction product. And I hinted earlier today, you know, if somebody puts their name on a reaction, it actually makes it harder to remember because it has nothing to do with the reaction. That's not a person's name. That's actually a good name here, isn't it? What two functional groups are present? Aldehyde, ALD. Alcohol, OL. I like it. Okay. The only thing I don't like about the name aldol is that this reaction also works with ketones. And you don't get an aldehyde and an alcohol, you get a ketone and an alcohol. I mean, you could call it a ketol reaction, and they did for a while. But it's the same reaction, so let's not have two names for the same reaction. Just remember, it was named after the aldehyde being the reactant, and it ends up being an aldol product because there's an aldehyde in it and an alcohol. And use some Greek. What position is the alcohol relative to the aldehyde? I need a Greek letter. Beta. It's beta. Aldol reaction product is a beta hydroxy aldehyde. That's here. And if you started with a ketone or a beta hydroxy ketone, not here. If you start with a ketone. And we call it ARP. And that's the answer to which letter question. Why is this called an ARP? C. I think the explanation is pretty, I don't have to write anything more, do I? C. Okay. And I'll just, ald. Hydroxy is a alcohol, right? Alcohol. Aldol. That explains it right there. Aldol. Reaction product. Okay. Let's take a look back and see what questions we didn't answer yet. What is the pK of the alpha H? 20. Give a mechanism for each step. Yeah, we're doing it. Why is this called the ARP? Yes. It's the aldol reaction product. And you get, when you react to beta hydroxy, you get a beta hydroxy aldehyde or ketone, and they're called aldol products. And then we're going to make this thing into that thing way up there. I think we can see them well enough. Tell me. No, O attacks an H. I like it. Which O and which H? Yes. No. The H on the OH is going to leave like this. So it still has that H. Going to pick up a new H somehow. How about I do it this way? Make your life easier. How about I do it this way? Make your life easier. That actually gives away something, doesn't it? Blue implies that this H here is also blue. The blue on the carbon means that's a blue H. So what H are we going to attack? I like how she said that. She said the alpha H. Yeah. Because you get a pi that way. Well, that's not an arrow. I'm going to blow it up. Not taking any chances. I want it to become a pi. And this guy, bye-bye. There you go. And that's another meow, right? Meow. So it's a catalyst twice. And you also generate your Aldol condensation product. Oh. So be very careful how you talk here. Don't use those words when you're saying what happened in the last step. Don't use this word. What's happening in this last step is not condensation. You already did the synthesis part. Condensation has synthesis and dehydration. Exactly. So you dehydrate this product to get this. The synthesis was done way back in this step here. Right? Yeah. So overall, it's a condensation. That's why it's called a condensation product. The last step is a dehydration. And we get all the answers. Why is this Z and not E? And that, we'll just do a quick look down here at the product. You got the one that's drawn is here. And the one not drawn, but it says in the comment, that one's E, right? Or E. This one's Z. And the reason is here. sp2 equals flat equals not. What's the word that says takes up a lot of room in a small amount of space? Not bulky. If you're sp2, you're never bulky. Like a benzene ring, a funnel, that's like a knife. Is that bulky? You think of knives as bulky? No. Edge. So I'd rather have that group. I'd rather have that group near a bulky group than a bulky group near a bulky group. Look, bulky on bulky here. That's bad news, right? So that's a good question. And Aldol condensation product. Why is it called an Aldol condensation product? I didn't answer that really. I just said what ACP stood for. We did a synthesis. And then dehydration in the last step. In the last step. Dehydration synthesis is condensation. Okay? We didn't do the mechanism for the next one. Double activity. What I'm going to do is pause the video and blow up the second part only for the next page. Pausing. All right, he figured it out, and we're back. So I copied the other one over here, and we'll do it down here. You remember what the first step was?
Okay.
Grab an alpha H. I got another question for you. How many alpha H's does this molecule possess? 8. Oh, there's 8. Now, which ones are the appropriate ones to make that ring? I'm just, guys, when you're stuck on a mechanism and you don't know where to start numbering stuff. Carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, carbon 3 is a carbonyl. 2, 1. I see an alpha H. It's called number 2, right? I'm going to put that H on there. Alpha carbon, yeah. 3, 4, 5, 6, 7, 8, 9. Oh, the carbonyl 7 got attacked, didn't it? So step 1, take the alpha H off the right position. You can't do a two-stepper here because carbon doesn't start with a lone pair. We'll do a two-stepper shortly, though. 4, 5, 6, 7, 8, 9. And lone pair and a minus. You want some numbers? I'll just go 2, 3, 7. I'll move the 7 a little. Oh, wow. 2, 3, 7, 9. What's next? Attack the carbonyl in red. What's after that? Because we're going to combine. You're going to get an O minus. And remember, you made H2O in step 1. And an aldol product has to have an all. You don't have an all, you have an O minus. So step 2 is? Okay, grab a proton from the water using what? Because you have to draw that what first? The lone pair on that O. Grabs an H from water in a not red color. That's green. And you can go straight to your aldol reaction product in 2 steps, and then I'll show you a nice 1 step to get to the condensation. It's a lot simpler than the previous one if you combine steps, but it's not. It's got all the information. So it's not simpler. It's got it all. Here's your new bond. Here's your FO, got that. I got my OH. Yeah, wanted to be a black H, why not? And that's it. Hydroxide, you're going to need a hydroxide. And what's hydroxide going to grab? Which H? Which carbon? Give me a Greek letter. Alpha. She said, grab the H from the alpha carbon. There you go. So yeah, you're removing 2 alpha H's in this mechanism. First one to do the reaction, second one to do the dehydration, which is the second part of the condensation, right? Grab H, make pi. Well, grab H, make pi. Hydroxide leaves, meow. Meow number 2, meow, meow. It's not a bad little mechanism, is it? Perfect conclusion to the day is what I say. Yeah. And we'll stop the share. That's it.